All right. So we'll talk about the 2024 AMC 10A problems in this video. So the first one we have is just the value of this subtraction. So, we don't want to multiply these manually because it's going to be tedious. So when we look at the numbers carefully, so there is like a couple ways maybe we can approach to make it a bit nicer. So, we have 99, but this is 101. Maybe we can write this guy as like 99 plus 2, or this is 101 minus 2. So either way should be okay, but let me try this guy as 101 minus 2 and then multiply with the other one. Okay, so let's try that way. So 101 times 9,901 minus, so this number is 101 minus 2, which is just 99, times 10,101. Okay, so if you expand these now, so we will see how this is going to be useful. So 9901. So we multiply 10,101 by 101. So that should be minus 101 times 10,101. So now we have this minus, this is also negative, so that should be plus. So 2 times 10,101. Okay, so we have 101, we have 101. So if I pull that as a common factor, so that should give us 9,901 minus 10,000. Maybe I should write it. So 9,901 minus 10,101 plus 2 times this one. We can multiply, which is not too hard to do so. So that will be 20,202. Okay, so we have 9,901 and 10,101. So from 901 to 10,000 there is 99. So from 10,000 to 101 is like 101 additional. So the difference between these two just 200, but this is going to be negative 200. So that should be 101 times negative 200 plus 20,202. So we just like to be careful. So this is a product. So if you multiply 2 by 101, so you will get 202, but there is 2 zeros next to it. And now we have negative in front, so that should be plus 20,202. So this is 20,200. This is 20,202. Since this is larger than this by 2, so that is the choice A. So you can do this problem a couple of different ways, but I think this is not too bad. So let's see the next problem. So the second question, it's kind of wordy. We are told the model used to estimate the time it will take to hike to the top of the mountain, and then we are given the equation. And then T, L, and G represent different stuff. So the model estimates it will take 69 minutes. Like when you are dealing with this, like make sure you really look at the units carefully, because if there is some changes, we have to convert. But in this case, I guess they are all good. So we have 69 minutes, and then minutes is just a T. So I'm going to write it 69 equals A times L, and L was the length, which is, we are told, 1.5 miles. So that should be 1.5 times A. And then G is the altitude in feet. So G is in feet, so that's 800. So that should be plus 800 B. So that's the first equation. But it says as well as if a trail is 1.2 miles long and ascends 1,100 feet. So we will get the same time. So which is why we actually can say this is equal to 69 again. So 1.2 miles times A, and then 1,100 B now. So this is what we have. This is some of equation. And then how many minutes does it take to model? I'm going to say that's equal to T for our minute. And 4.2 miles, 4.2 A plus 4,000 B. And this is what we are looking for. So if you can find a way to find the right side of this equation by using this without solving the system, that might be nicer, but I will just go ahead and solve the system. So if you have some other ways, just go ahead and try for sure. So like this 15 and this is 12 looks like the least common multiple like 60. So if I multiply this by -4 and this by 5, so that will be like 6. That will be 6 as well with the opposite sign. So that will make a nice equation. So if I multiply this, that will be 5 times 69 minus 4 times 69, which is just going to be 169. And then A's will cancel. That's why we multiply by these. So you got 5 times 1100. So that should be 5500 B. And then 4 times this will be 3200 B. So 55 minus 32, which is going to be 2300 B. And this is going to be 69. So cancel 23's. That should be just 3 divided by 100. So 3 over 100 is our B. So we got B as 3 over 100. So now we can just plug into the equation to get our A. So I'm going to use the second one. So if I do that, so 69 is equal to 1.2A plus 1100 times 3 over 100. So cancel these zeros. So you got 33. Let's subtract from both sides because 3 times 11, 33. So that should be 36 equals 1.2A. We can divide both sides by 1.2. So A will be 36 over 1.2. But I can multiply both sides by the top and bottom by 10. So to make nicer. So that should be just 30. So A is 30. So now we can plug into this. So if you multiply 4.2 by 10, that will be 42. So you will get 3 times that, which is 126 plus. And then we have 4,000 times B, which was 3 over 100. So cancel these. So you will get 126. And then that will be 12 with 0. So that should be our answer. Okay, so that will be 246, which is choice B. Okay, so even though this was like the second question, it took a bit longer because it is wordy. So if you kind of don't see this immediately, you can always like move on and come back because time is important. Anyway, so let's see the next. So number 3, so n be the least prime number that can be written as some of the 5 distinct prime numbers, okay? And what is the sum of the digit of the value of n? So let's list the prime numbers, the smaller ones, so 3, 5, 7, 11, 13, 17, 19, and 23 will continue, right? So we want to find the A number. That should be our least prime number when you add the 5 different prime numbers. So if you want to try the first like one, so if you add these, that's 5, 10, 17, so 28. So when you add these guys, right, that's the 5 of them. So that's 28, that's an even number, which is not a prime number. And just imagine like when you take the 2, because that's the smallest one, then everything else has to be odd numbers. So when you add 4 any odd numbers, you always get even. If you add to that even sum, you always get even numbers. So which means if you want to get a prime number, then you should actually you shouldn't get 2 at all because you will always get even numbers. So which is not a prime anyway. So now as soon as we have this, we can try like 3, 5, 7, 11, and 13. So when you try this, like we skipped 2 and then we added 13, which is 11 more than this guy. If you add 11 more than to this guy, so you got 39. So this should be 39, which is another prime number. So at this point, we like to be careful because we are trying to find the smallest prime with using some prime numbers. And this is the number we get when you try next smallest ones, right? This is what we have. But this is not prime number, so that means we are going to get something larger than that, which is going to be like 41 or 43, maybe even 47, if this is not going to work out with any of these. So the goal is to see if this is possible with 41. But to get 41, this number like should increase by 2. And then when you look at the next prime, which is 17, so we should have two more than our previous sum to get 41. But it looks like if you add 17, you are increasing that by 4. So that means the sum will increase by 4 at least, which is going to be 43, which is like 41 is not possible. So I hope that makes sense, because this is the smallest number you can get when you add the smallest primes other than 2, which is 39, but that's not prime. So which is why you just look at another one. But the smallest number you can actually add into that sum is 17, which is going to give us 4 more than the previous prime, which means our sum has to be increased by 4, which looks like 43. So let's see if this is possible. So if I try 3 and 5, 7, 11, and 17. So instead of 13, I added a 17, which means our sum increased by 4. So you can double check. That's 10, 15, 26, and you got 43. So this is 43. And this is actually the smallest prime number we can get with this restriction, because there's no way to get 41, because we just need to increase by 2, but we cannot really do such a thing. Because if you really remove one of these prime and add any other prime, your increase will be more than 2, which is why 42 is not possible. 43 is the smallest one, which is with these guys. So if that's the case, and is our 43, so we are looking for the sum of the digit, which is going to be 7, which is choice B. So that was an interesting question. So let's look at the number 4. So the 2024 is written as sum of not necessarily distinct 2-digit prime numbers. What is the least number of 2-digit numbers needed to write this sum? Okay, so it's kind of hard to understand what's going on, but basically asking how many, what would be the least number of 2-digit numbers that needs to be used so we can get 2024 as sum of 2-digit numbers. Okay, so I'm gonna try this, 2024, if I divide this by 10, because 10 is the smallest 2-digit number, so that will give us 202 plus 0.4. And if I divide 2024 by 100 instead of 99, because that's not gonna be fun, so you will get 20.24, which means if you choose a number that's really close to 100, let's say you choose all these 99s, right? Then your sum will be 2024 if you have at least 21 of these, because if you have 20 of these 99, that's not going to be enough. So let's try 20 times 99. So if you multiply 2 by 9, which is 8, so that's going to be 18. So you got 18 plus 1, 19. So you got 1980. So, or you can see that this is like 2099 or 9920, or if you had 120, that would be 1000, 2000, but that's one lesser 20, which is 1980. So that's easier to see as well. So to get this sum, we need 20 of 99s. Okay, so you have 99, 99, all these 99s. So 20 of these. 20 of these. Okay, so 20 99s, I will say. 20 99s. So, but when you add 20 99s, you are actually not getting this number. So if you want to get this number, we need 20 plus 24. We just need another 44. So we can add this 44 to get the entire sum as 2024. So we have 20 numbers right here as 2-digit. And then this is the next one, that's 21. So that's the least number of 2-digit numbers can be added is 21. So that is our answer. Okay, so let's see the number 5 as well. So what is the least value of n such that n factorial is a multiple of 2024? Okay, this is actually nice because, this is the 2024, and then they're asking a question about the prime factorization of the year, which is usually happening every year. So 2024 is actually 2 to the 3rd times 11 times 23. So if you didn't know before the test, maybe it's okay. You can still get it after if you try. finding prime numbers. That is a divisor, but this is the prime factorization. And the question says, like, what is the smallest number such that n factorial has to be a multiple of 2024. So we want this to be integer. So in order for this fraction to be integer, so n factorial should have every numbers in the denominator. So we know n factorial over 2 cubed times 11 times 23. So in order for this to be integer, so the n should have like 23 at least, because we have to cancel the number 23 and then in the denominator number 23. So only way that will happen if n is at least 23. So we should have this guy at least. If you have 23 factorial, that means that has 11 and 22, which means you already have more than 1 11th in the numerator. So that will cancel 11th. And then you have way more 2s. So we just have no concern with that. So at least we should have 23 for n. So that was the number 5.